stochastic frontier model using panel data. So for that we have some files. Okay. Discuss about the technical efficiency in single equation panel model. So, sir has already told about the panel data regression and the mathematical form of all the models. So we have three models. One is fixed effect model, other is random effect model, and the third is the time invariant model. So in fixed effect model, this is the functional form of the fixed effect model. In this, how to check that this variable is fixed effect model, having fixed effect model, or having random effect model, or having time invariant model. So this is the functional form. If your alpha is, this is the functional form, these UIs are the inefficiency term. Okay, and this VI is the residuals, or you can say white noise. Then this alpha is the beta naught minus UI, and this alpha I, if this alpha I is your say fixed parameters, if alpha I, or you can say UI having fixed parameters, that means your model is a fixed effect model. Okay. So the panel data regression, we have used the data given by sir, which is panel data 1, and this has some variables.
Sir, can you please move to previous slide? I have to know.
Okay. So this is the model. You can, if you want to write, you can write. So in this model, these exercise are the variables, input variables. Okay, and as you all know, what is panel data? Panel data is the combination of time series and cross-sectional data. Okay, so first step is to check whether your variable having fixed effect model, or random effect model, or time invariant model. Then you have to go for analysis. So this is the data which is used to regress the panel data, and the variable name is a code. Code is the name of any country. This Y are the years from 1960 to 1987, and having 2296 observations in total, and this Y is the output, which is GDP. Okay, and K is the capital, L is the labor, and these are the codes for Stata. This first code is global. Global means there is a global macro. If we have more than hundreds of the input variables, then at each time you have to write each variable for any regression or for any model. Then this global macro will make a single variable of all the variables, of all the independent variables. It makes a single variable. That is, this is the command. You can write global space and then variable name. This is the variable name. I have put x var, means x variables. Okay, and these are the variables. Those are stored in that particular variable. That is x var. If you have more than 3 independent variables, then you can store all the variables in a single variable. This is the command, that is a global command for storing more than hundreds of the variables in a single variable. Okay, then you can call them by giving that command xvar. Okay, and this x set xt set is the command to set the panel and the time variable. Panel, how many countries are there, how many years of data is recorded here. Okay, so you have to set the panel data in two codes. For example, first is for a panel code and second is for a time variable. Okay, so in this data your code is your for countries and this YR is your for years, that is your time data. Okay, so first if you run these two commands you will get this type of window, and you can check that this this command is the panel variable, means code. Okay, and then second is a time variable, and time variable is a YR from 1 to 28. That means we have 28 observations for each country. Okay, and this is the code. Code means how many countries are there. The same number of countries are there and the same number of years if you have, then your data is strongly balanced. Okay, otherwise your data is imbalanced. So first you have to check if your data is balanced or not. Okay, by giving this command xt set, and to set the panel you have to use this command, and in this we have also used generate command for generating the logarithmic values, and this is the global command, global macro command, in which we have stored three variables in xvar. Okay, so this is the output window, and then this xtreg is the command to regress the panel regression. Okay, if you want to use the panel regression, then you have to write xtreg followed by variables. For example, your dependent variable is ly, then second is a number of independent variables, but we have stored all the independent variables in a xvar. That's why we are using this command. This dollar is the sign to use that these stored variables in a single variable. Okay, here xvar is not a single variable, it has three input variables, and this fe stands for a fixed effect model. Okay, this fe stands for a fixed effect model. After clicking enter, you will get this type of window. Here is the output of the panel data regression. You can check here. This is the fixed effect panel regression. Okay, now you have to check whether you can check the number of observations. These are the number of observations, and these are the number of groups. How many groups are there? So we have 82 countries and each having 28 observations. That you can check from here. Average 28, maximum 28 or minimum 28. Means observations per group. In each group there are 28 observations, and we have 82 total groups. Means code means number that your country. So we have 82 countries data. Okay, and for each country we have 28 observations. Okay, then come to next. So this is the correlation between UIs. UIs means
Inefficiency.
inefficiency term, and XB means fixed parameters, means xis of your independent variables. Xis are your independent variables, but we have fixed their parameters. So this is the correlation between UIs and xis, and this should be maximum for fixed effect model. And this is the overall significance of the model. You can check, and these are the variables having positive, negative impact on output variable. So we have used this xvar command, and you can check that all the variables are in the model, because we have stored all the variables in the xvar command. So this lk means log of capital. So you can check this capital is significantly affect the GDP or not. So this value is significantly affect the GDP, and this L is the next input variable. This YR, look at this YR is the year, and year having this no positive. This is the
थोड़ा zoom
okay.
कर दो.
पॉइंटर ऑप्शन से ऊपर फर्स्ट पेन में सर
लेजर पॉइंटर
नहीं, सेकंड मेन्यू में सर जो खुला हुआ है उसमें
ओके ओके ओके
ऊपर 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 की
पॉइंटर ऑप्शन
ये नहीं होगा क्या सर?
ऊपर जूम इन लिखा हुआ है सर.
okay okay. So this is the coefficient of YR. What does it mean? It means 0.7% of the 0.7% GDP is increasing. It will increase, means yearly 0.7% GDP is increasing annually in each country. Okay, and okay, now you can see that the coefficient of Y on YR, that is 0.007, implies that the productivity that is your GDP has increased in real term by 0.7% per annum on an average across all the countries over the period. So you can interpret each and every independent variable by their coefficient, and you can check whether these coefficients are significant or not. One more thing you can check that is sigma u. Sigma u is the standard deviation of inefficiency term. Okay, and sigma e is the error term, and this rho is the fraction of variation due to inefficiency term. Okay, so the next is these are the commands to predict the technical efficiency. Why we have used these commands? Because this is the formula which I have taken from the search book, which is stochastic frontier analysis using Stata. So this is the formula for finding the technical efficiency. Directly we cannot find the technical efficiency, so we have to use these formulas. For these formulas So these are the commands. So this is the command. First we have to predict u. U is the efficiency term. Then find, or you can say the generate a new variable. Okay, that is maximum of this minus that ui's. Okay, you can check from here. Maximum of alpha is minus alpha is cap. Okay, this is the formula for ui's. So you can check where find the maximum value minus that u value, and then take exponential of that one. This is the formula. You can check. This is the formula. Exponential of minus of ui cap. Okay. So we have used this formula over here. So efficiency is equal to exponential of minus of u star. That is some variable name. So minus of u star. Okay. By using this formula, we can calculate the efficiency. So this is the efficiency, and this is the summary of efficiency. So now you can check after getting these commands. This is the window. Okay. Now you check the this is the first command to generate. Double means double command is used to specify the value up to 16 decimal places or more accurate value. Double command is used to find the more accurate value. Okay, in normal case we have around 8 decimal values, but if you use the double command, then you get the more accurate value. Or if you have 0.00000 last में 1 means, but it's after using this command, this will give the values up to 16 decimal places. So this double command is used for a more accurate more accuracy of the values. Okay, so decimal place is up to 16, and then this is the formula for efficiency, and this is the summary of efficiency. Now you can check these are the number of observations, and this is the mean of efficiency. Okay, average efficiency according to this panel regression. So next is the random effect model. So random effect model, in this okay, instead of assuming this alpha has fixed okay, instead of assuming alpha I and ui's as fixed parameters, it is also possible to assume that alpha is a random and uncorrelated with the regressor. Means it is assumed in random effect model that the correlation between ui and xi is significantly 0. That means there is no correlation between them. So this is the assumption for a random effect model. Then these are the commands for random effect model. So first we have global macro, then second for panel theta or panel variable or time variable. The third is the panel regression with the random effect model. So this R is the random effect model. Okay. So now we can run these commands, and you can find the this equation. Okay. So these are the equation. Now you can check the correlation is equal to correlation between ui and xi is 0 assumed. Why 0 assumed? Because we select a random effect model. So this is the assumption.
Uncorrelation का.
Okay.
So uncorrelation से.
Uncorrelated. And this again the number of observations and the number of groups and each group having 28 observations. Then you can check the overall significance of the model, and then you can check the significance of each and every variable by checking this p-value, and you will get this value, and this here again this yr is the this impact of years. Okay, so this value is okay, this is the misprinting. This value is 0.00 okay 1, it is okay. The coefficient on yr implies that the productivity, that is GDP, for a given level of capital or labor has increased in real term by 0.1% per annum on average across all the countries over the period. Okay, so these are the two models which we have explained. That first model is panel regression using fixed effect, and the second is panel regression with the random effect. Now, okay, we have done this one. So now the next command is SF panel, means stochastic frontier panel model. Stochastic frontier panel. So this is if we do not have this command in our Stata, then you have to install by writing SSC install SF panel. Then you can install that command in your Stata. Okay, first without installing, if you write SF panel command, then there is a message that this command is not yes, this command does not exist in the software. You can install that command by using SSC install command. Okay, any command which is starting from S, any command, SF cross, SF panel, SF pen, there are so many commands. Then you can install them by writing SSC install command. Simply write SSC in space install and then the command name. That function will install in the Stata. Then you can use. So first you have to check whether your command is in the Stata or not, and if not, then you have to install that. And this is the panel variables. Means you have to set the panel variables. Earlier we have already discussed. And this is the panel command, SF panel. This is a dependent variable and these are independent variables. And this is the model. Then you can write the name of the model. And the TFE is a true fixed effect. Okay. And this dist is the distribution. And this TN is a truncated normal. Okay. And this ORT is a orientation. And O means a good. And this E means a mean command is used to find the expected mean, or you can say the conditional mean of UIs. UIs mean inefficiency term. there is a inefficiency terms ui, and this variable h is the variable. We are checking that this variable is responsible for the inefficiency or not. Okay, then we have to use this e-mean command. If you want to check any variable is responsible for the inefficiency, then you have to add this e-mean command. Okay, for panel data. Okay, and this is the predict command. JLMS means John Rowe has given this. John Rowe and their group has given this command to find out the efficiency. Okay, and this is the summary, to get the summary of technical efficiency. So the first step is to run the stochastic frontier model using tab based or inbuilt functions of the Stata. Then we'll try with the commands. So first you have to go for statistics, then go for linear models, and then come to panel data. Okay, panel data, and then the frontier models, and then the frontier models. When you click on the frontier models, you will get this type of window. Okay, this is the first window. This is the first window when you click on the panel data, frontier model, and then panel data. This is the first window. In this window, you have to give the model, means your dependent variable and your independent variables. Okay, and this is the panel setting. You have to set the panel. Which variable is your panel variable and which variable is your time variable. Okay, so when you click on this panel setting, you will get this window. Okay, and in this window, the first is a panel ID variable. Panel ID means your specific region name, or you can say your country name, or you can say your state name, or you can say your district name for which you have done the study. So this is your panel ID variable. So in this case we have code is the panel ID, and this time variable is a year, that is a YR. Then you have to select these two variables for a panel declaration. Okay, after declaring this panel, simply click on OK, and then again OK. You will get this type of window, and this window is this is the command. Okay, this is inbuilt command. This is the inbuilt command. First you have to check this panel variable, that is code, then time variable, that is year. How many years are there? 1 to 28, which we have 28 years data, and this panel variable is code, and this is the strongly balanced data. Okay, means in each variable having the same number of observations. Okay, so these are the commands which are inbuilt commands in Stata, and after getting this, this is the model. You can check the model, time invariant inefficiency model. Okay, time invariant inefficiency model. Again, you can check the number of observations, the number of groups, and number of observations in each group. And this is the overall fitness of the model, and these are the independent variables having impact on dependent variable. Okay. Then you can check whether it is significant or not. The first variable is significant, second is also significant, and this constant is also significant, and this mu is the inefficiency term. Okay. So after getting this window, then what is the next step? First we have to check which variable is responsible for the productivity, or you can say the change in the output variable. First we have to check that one, and these two variables, these two independent variables, both have significant impact on the output variable. Okay, and the next is how to find the technical efficiency. Then you have to write the codes. Okay, this is the second SF command based stochastic frontier panel. We have already discussed this command. Okay, this is the command SF panel command. Previous we have discussed the inbuilt function of panel data, and this is based on SF panel command, stochastic frontier panel. Okay, so again simply write the code of the SF panel, and then dependent, and then followed by independent variable, then model, then distribution, then orientation, and then e-mean. E-mean within bracket H means we are checking that this H is having impact on inefficiency or not. It may be anything. For demonstration we are checking that H is having any impact on inefficiency or not. So after this command you will get this window, and this is the two fixed effect model truncated normal, because we have given Tn in the model. So these are the number of observations, these are the number of groups, you can check it, and this is the overall significance of the model. Now you can check this one. These are the frontier model, stochastic frontier model. Okay, you can check the impact of each and every variable on the dependent variable. Your dependent variable is Ly, and your independent variables are these and this. Okay, and this mu is the inefficiency term, and this mu has this H. This is the regression of inefficiency term with the H variable, because we are interested in checking that is there any variable which is having impact on inefficiency. So we have to check the coefficient and then the p-value. P-value is significant. You can say that this H is having negative impact on inefficiency, but positive impact on efficiency. That means if H is increasing, efficiency will also increase. Okay, and then how to generate the efficiency? So these are the codes, you can write them. These are the codes. Predict. This IFF means inefficiency. You can write any name to the variable. Okay, I have written IFF, inefficiency, that is U. U is inefficiency. So when you write predict inefficiency, comma U, you will get inefficiency values. And when you write predict any variable name, JLMS, John Rowe et al., they give the that particular estimate for the efficiency. So this JLMS command, predict variable name, JLMS means it will give us the efficiency values. That's why I have written this EFF, that is efficiency, and then summary of efficiency. then you will get the summary of the efficiency. So this is the mean of the efficiency, okay, and these are the minimum value of the efficiency, and this is the maximum value of the efficiency, okay. So this is the stochastic frontier panel model, and the command is a SF panel, and to predict the efficiency you have to use a JLNS command, predict variable name comma JLNS, okay. So this is all about the stochastic frontier panel regression, how to use any variable to check whether this variable having impact on inefficiency, or you have to check whether the variables are significantly affected the output variable, or you can say the according to this example we can check the capital and the labor is having any impact on the GDP, okay. So this is the panel data regression. Now if you have any doubt, or you can say any question about this SF panel data, how to run, or how, what is the command, or you can also come to check and run the command from boy side. One boy, anyone who is interested to run the commands, I will help.
सर शुड आई
Yeah, you can come.
जाओ आप में से कोई
आप में से चले जाओ
Anyone you can come.
प्लीज
फिर अरे सर बताते रहेंगे आप करते रहेंगे।
This is hands-on practice, na? So you have to come. This is hands-on practice,
नहीं यार
hands-on session.
चले जाओ कोई
So you have to come. Anyone you can come. Anyone.
आप में से कोई जा
नहीं
अरे आप
इन्होंने तो कर रखा है आप जाओ
सर बताते रहेंगे कमांड आपको फॉलो करना है।
Okay. So this is Stata. You can sit here.